Hey guys, got another Project Euler here for you. Continuing on, problem 11, the largest product in a grid. In the 20 by 20 grid below, four numbers along a diagonal line have been marked in red. 26, 63, 78, 14. The product of these numbers is 1,788,696. What is the greatest product of four adjacent numbers in the same direction, up, down, left, right, or diagonally, in the 20 by 20 grid? Alright, so going through here, 20 by 20 grid, we're gonna have an array of numbers. 20 by 20, we'll say row by columns. It'll be a two-dimensional array. Ooh, adding another dimension. But it won't be too bad. Basically, we're gonna have to loop through, you know, the rows and the columns, and then see for, you know, as we're looping through, multiply together four adjacent numbers in each direction and see what they equal, and make it equal to some maximum because we need the greatest product. So we'll get to that, I suppose, on the notepad. Now this one's similar to a bunch of them. So far we're only gonna have one include for the standard input-output header, just so we can printf our answer to the screen, because that's, you know, I like doing that. Our good buddy main. Now we'll be going through the columns and the rows, basically looping through each, or one loop for each. So I'm gonna have a couple loop counters or loop iterators. Maybe to make it look better, we can make this say row by column. I'm just gonna go I by j, it's fine. And then each of the directions we're gonna need a product, right? So I'm gonna put that here. I'm gonna call this horizontal product or hors product, vertical product, and then we need a couple diagonals. For the purposes of this one, we're gonna be doing, what's an easy way to say this? We're gonna be doing diagonally, kind of like how these ones are laid out. So we'll say upper left to bottom right, we'll be doing this diagonal direction. If you think of the 17, say like an X, we'll be going like, you know, the upper left to bottom right for adjacent. And then we're also going to be doing the upper right to lower left to make like the other side of an X, like these four. We'll be going in these two directions pretty much to get the diagonals. So we're going to have two diagonal products for that. That's what these will be. I'll call it diagonal. We'll do upper left to lower right, I guess. And then we'll have diagonal upper right to lower left. And then we're gonna have a max product, which will hold our answer at the end. For initializing these things, we're also gonna have the grid, but I'm just initializing these to start off. The counters will be 0. I'll probably move them around later. Let's do that actually. Let's initialize our product and the counters to 0. And then for our big old number array, we're gonna have a two-dimensional array, so we'll have, you know, two of these, right? It'll be 20 by 20, which is what it says. It's what it gives us. I already have this laid out. I'm just gonna copy paste because it's easier for me to do that. So there you go, haha. Now this one, you'll have to massage the data, massage the numbers a bit, because you see in the grid here, you'll have stuff like the first two are 08 and 02, 08, 02, and here they're just 8 and 2. If you leave them 08 and 02 by default, at least for me when I'm compiling and trying to run it, C will count those, or my GCC compiler, whatever, will count those as octal, and it won't allow me to use them. It'll say 08, you're trying to define an octal number, an octal 8, because you can have binary, hexadecimal, and octal in C, among other things, but we just want them to be integers. I declared an integer array, so to count them as integers, we cannot have leading zeros, so it just has to be 8 and 2. So you have to do that for all the numbers, and it's annoying, but that's life. Same for the zeros, it'll be like octal 0. But after you do that, it'll look something like this. I just lined it up nice so you can see 20 by 20, hey. Initialized our stuff, and we'll get to the loops. It's a pretty simple one, even if it doesn't look like it to start off. We're just going to be doing some nested for loops to nest through the rows and the columns for each of our products. So I'm basically going to have 4 sets of 2 loops to go through each of our products, horizontal, vertical, diagonal 1, diagonal 2, upper left, lower right, upper right, lower left. So I'll start off with the horizontal product. I equals 0, I less than 20, I plus plus. This will go through all of our rows. I'm counting in grid 2020 is sort of this 20 being I, this 20 being J, I being row, so left to right, and then the second one being column, up and down, vertical. That's how I'm computing this and writing it out. So this first for loop will go through all the rows, basically 0 to 19, because zero-based indexing, 0 to 19 being basically the first row to the 20th. And then we're gonna limit our columns in another for loop. We're gonna have it be, space this out because OCD people go crazy. We're gonna have it be limited. Well, we're gonna have this one go through 20 as well, actually. No, wait, no, we're not. We're gonna have this limited to 17. The reason we're limiting the columns to 17 is because for the left to right, our horizontal product, to get the 4 adjacent numbers, we don't need to look past this one. We don't need to look past 16 in the array, or the 17th column, because to get the 4 adjacent, we can just basically spread out from the number up to 3 places. So we'll be counting, we'll be going to here, and then we'll be counting these 3 in that calculation. There's no reason to go all the way forward. So we're basically going to calculate up to here, and then we'll include the last 3. We don't need to go start and go backwards. All of these are only going to be going in one direction. We'll only be, we'll be going left to right, say. We don't need to go right to left and start at this end and go up to here, say, because we'll already have our horizontal product from going in the first direction. But anyway, to fill this out, I'm finding our horizontal product here. Suppose I could write these out and make it easier, right? Horizontal product, left to right. But to be finding this, looping through the grid, we're gonna start at our origin here, 0, 0, ij. They'll both be 0 at this point. So we'll be starting in the upper left, because this goes left to right, up and down. And this being 0, 0, this being 19, 19, or the last place in our grid. We'll start it at 0, 0. We're gonna multiply because we're finding the product. The next position will basically be 0, 1. We'll have j plus 1. We're gonna be doing 4 numbers left to right, so we'll have, in a 20 by 20 grid, we'll have 0, 0, 0, 1, 0, 2, and 0, 3. And then we're gonna increment 1, and we're gonna, in our columns, so we'll shift right 1, which is what this is doing. And we'll have, once I will increase for the loop. Yeah, we'll increment 1 through j, j will be 1. So we'll have 0, 1, 0, 2, 0, 3, 0, 4. J will increment again. We'll have 0, 3, 0, 4, 0, 5, 0, 6, and so on and so forth till we limit it to 17, which will be about here when it equals, well, it'll be 16, but still. 16, 17, 18, and 19. So we'll reach out 3 to the right from our current number in our row. So we'll just multiply our origin by the number 1 to the right, and then 2 to the right, and then 3 to the right, which is j plus 1, j plus 2, and j plus 3, respectively. And that is how we get that. Then after that goes through, we'll have our next row. We'll do 4, we'll shift 1 over, we'll do 4, we'll shift 1 over, do 4 up until this, which will have the last product of that row, and then we'll go through all the rows. So we should go through all of it and get our horizontal product at the end. But after each row here, or after each group of 4 numbers, we're going to check if it is the maximum product, because we have to find the maximum out of the whole thing. And if it is greater, then it will be the new maximum product. And that takes care of all the horizontal, all the left to right products. So that's one direction down. So then we need to move on. I'll just copy paste this and change. We'll go to our next one. We're gonna do vertical next. For our vertical product, we are going to limit our rows to 17 this time instead of the columns, because we're going to do the same thing sort of left to right. We're going to limit to here because we're going to reach out for the last 3. Vertical, we're going to limit down to about here because we're going to reach out for the last 3 in a downwards fashion. So we don't need to go past, we don't need to compute the last 3 rows. They'll already be in there. We don't need to loop through them explicitly. So that's why we're limiting that here. But we do, or we will, go through all the columns. Sorry, you guys are probably yelling at me the whole time, weren't you? Increment your J's. That's okay. We will go through all the columns though. We'll just limit ourselves down to about here, and then we'll compute the last 3 to get the vertical products. So that'll be good. So of course in this one we'll do kind of a reverse, not really reverse, but horizontal, shifting over the column by 1. This one we will shift over the row number. This one will be going down. We shifting that by 1. So instead of j plus 1, 2, 3, we'll have I plus 1, 2, 3. Yes. That should compute our vertical products. And then we'll find the max, of course, after each group of 4, if it is greater. That'll take care of all the horizontal and the vertical. That's 2 directions down. Now we have to deal with the diagonals, which aren't that bad. We just have to go at it in a sort of stepping motion, which I'll lay out here in a second. Yeah, I'll just spell it out more. We'll call it diagonal upper left to lower right or bottom right. Upper left to lower right product. This one we're gonna limit both the column and the row values under 17 for the sole purpose that we're starting at 0, 0 still, upper left to lower right. So we're starting here. The first group of 4 we're gonna get is gonna be 8, 49, 31, 23. We wanna go upper left to lower right. And now we cannot go past, the reason we're limiting 17, 17 here is because once we reach at this point, I will be 16, you know, the last value where it's less 17. We can get 4 values here. We can get this one, this one, this one, and this one, but moving past, we can only get 3. It will not be 4 adjacent numbers, and it will not be valid. So there's no use looping past this number in this direction. That'll be for the column J. For the row I, there's also no point in limiting past here, because here you have 4 values, yes, but once you reach I of 17 here, you only have 3, and you can't compute 4 adjacent. So we're basically going to be going, leaving out this corner, sort of, and then leaving out like this corner, in a way. Or, you know, there will be groups there. I don't have any good graphing tool to show you that, but anyway, that's what we'll be doing. Stepping upper left to lower right. So if we see 2020, we go to IJ, we'll say I0, J0. This will be I1, step over. Well, this will be J1. I1 will step down, and then J1 will step over, and that's how we step diagonally. This will be IJ0, 0, I plus 1, J plus 1, I plus 2, J plus 2, I plus 3, J plus 3. And then that will loop through the columns to go horizontal up to the last 4 here. And then we'll loop through the rows and go down vertically up until about this 1, 2, 3, 4. Loop to about here, I suppose, yeah. But anyway, I0, 0, I plus 1, J plus 1, I plus 2, J plus 2, I plus 3, J plus 3. And that's how we'll do that. That'll be one diagonal direction. Then we still need the other one, which is to say, I'll be calling it upper right to lower left to go in this direction. And that should be our final direction we have to check to get the value, at least for this problem. Call this upper right to lower left. This one's a bit iffy, a bit weird, that's why I put it last. We will still limit ourselves row-wise vertically. below 17. And we're sort of still, we will still be limiting ourselves column-wise here horizontally, but we're gonna start at 3 and go less than 20. Also, I need to rename these. Sorry for not doing that yet. What did I call it? Upper left, lower right, ULLR. When you talk, you forget things. It's pretty fun to do. If I had a set script to follow, it would be easier, but why would I make a script? That reduces the fun. This one we're calling URLL, upper right, lower left. Upper right, lower left. All right, now this one, why are we doing J3 to J20? We are still limiting I 0 to 17, our rows 0 to 17. Now J3 to J20. J will start, we're doing upper right to lower left for this one. So we'll start here, J3, and we have to step basically backwards down to here to get the other diagonal direction. This way and this way. So that's why we have to start at J3. Start at J0, well, you can't reach over here to get numbers. The first point where you can get 4 adjacent numbers in this direction is here, so J3 to J20. So we're going upper right to lower left. That's why we're doing that. And then we're gonna be reaching out with I, so we don't need to go past the 17th value. We'll be reaching out. This will be like the last one down here. We'll be doing these 3. So I will be limited to here because we're gonna reach down. That's why we're limiting this. This one, we're gonna be starting at basically 0, 3, and then we'll have to do I plus 1, and then J minus 1 to get here because we're stepping backwards. I plus 2, J minus 2, I plus 3, J minus 3 being here. So I0, J3, I1, J2, I2, J1, and I3, J0. I plus 1, J minus 1. I plus 2, J minus 2. I plus 3, J minus 3. If that makes any sense, awesome. If that did not make any sense, I apologize. That is how I am explaining it, though. But this should go through the diagonal directions we need to, horizontal, vertical we found. So after all that, we can print our answer. Hopefully it's right, or else I look like a stupid idiot, right? But it should be good. I'm gonna print our max products, which we should have at this point, and we're gonna give a 0 back from the int main, make sure everything's good, all fine and dandy. So we can see if it compiles and if it's good. Spawn my PowerShell back here. Still using GCC. I may switch to Clang. I've been looking at that. Not that I need to, but I figure, I don't know, I like learning new things for no reason, so I might switch to that. This one being 11a for answer.c. Get the objects, we'll call it Euler 11a. Why not? And decorate, redeclaration with no linkage. Well, that's good. I did put an int there. I'm sure you were yelling at your screen the whole time. That's nice. This also needs a diag in front of it. If I did not make a bunch of mistakes, it would not be me, of course. So I do apologize if you were yelling at your screen the whole time. I did not mean anything bad by it. And the colors get messed up, but I know how to fix that. You call the reset color function for the console, and it'll fix that, which is awesome. Small dandy thing. But now that it works, we'll call Euler 11a, see what answer we get. Should be 706000674, which is what we get. Hey, it works. Which I'll show, get rid of that. 706000674. That is the answer. That is what we get. So it's pretty grand. I do like it. But yeah, that's all that's gonna be there for today. Sorry, I moved this a little bit. That's all that's gonna be there for today. But yeah, next time we're gonna go over problem 11, which will be, or problem 12 rather, sorry, which will be highly divisible triangular number. Fancy name for something that really ain't so fancy to figure out. But anyways, thank you for watching. I'll see you next time.